This question is to focus on maximizing the sum of the absolute values of two real numbers, x and y. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Let x and y be real numbers such that the sum of the absolute value of x minus y and the absolute value of x plus y is less than 6. What is the maximum possible value of the sum of the absolute value of x and the absolute value of y? First, we start by understanding the question. We are given that the absolute value of x minus y plus the absolute value of x plus y is less than 6. And we're being asked to find the largest possible value that the sum of the absolute value of x and the absolute value of y can reach under this condition. This is a classic question involving absolute values in two variables. Problems like this often benefit from a geometric interpretation. Then, next step, we recognize the geometry. The inequality describing the sum of the absolute values of x minus y and x plus y being less than 6 defines a diamond-shaped region in the coordinate plane. This region is centered at the origin and bounded by lines forming a tilted square, a rhombus. The key point is this. When you see a sum of two absolute values like this in two variables, it's often representing a rotated square. This gives us an intuitive way to approach the problem. Next step is to use symmetry to simplify the problem. To maximize the sum of the absolute values of x and y, we want to examine places where x and y have the same sign and possibly the same value. So let's suppose that x equals y and call that common value a. If x equals y, then the absolute value of x minus y is 0, and the absolute value of x plus y becomes 2 times the absolute value of a. The inequality then becomes 2 times the absolute value of is less than 6, which means the absolute value of a must be less than 3. So the sum of the absolute value of x and the absolute value of y becomes 2 times the absolute value of a. And this quantity must be less than 6 as well. That tells us the sum we're trying to maximize can approach 6, but must stay just below it. To find an exact value that works, we can try setting a to 11 over 4. That gives a total of 5.5 for the sum of the absolute values of x and y. And the condition still holds since the total of the two absolute expressions is also 5.5, which is less than 6. Final answer. The maximum value that the sum of the absolute value of x and the absolute value of y can reach, while staying within the allowed region, is 11 divided by 2. So, the correct answer is 11 over 2. When absolute values appear in two variable expressions, try visualizing them as geometric shapes like squares or diamonds. That often leads directly to the maximum or minimum values you're looking for. Geometric thinking is powerful. Absolute value regions often look like diamonds. Think in shapes. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.